Okay, P4.1, electrical charge. And the first thing I want to talk about is a quick recap about the atom. So inside the atom, you've got protons and neutrons. And protons have got positive charge, neutrals have got no charge, and the electrons, which are sort of around the outside, they have a negative charge. Okay, and what we mean by charge is something very, very similar to what we mean by a magnetic north pole and south pole. So from magnets, you might remember that a north pole will repel another north pole and it will attract a south pole. But the same thing is true for charges. So whereas magnetic poles is something that's possessed by magnets, charge is something that's possessed by protons and neutrons. And the key thing is that same charges repel, opposites attract. And we can draw that by drawing these field lines, and these are the field lines of force that are acting around our electrons and our protons. Okay, so they'll go out in all directions, so there'll be a force acting in all directions. That's the electric force acting all around it. Okay, and the closer together the lines are, then the stronger the electric field strength is. So you can see here where you've got two charges near each other, you get close to one, and right near the charge it's really quite close together, so the field strength there is really strong. Here you can see they're quite far apart, so the field strength there is quite weak. Okay, so the next thing I want to talk about is what happens when we make our charges unbalanced. Okay, so in your atom, if you lose an electron, so let's say that I've got 3 protons, 2 neutrons, and let's say that I've got 3 electrons whizzing around on the outside somewhere. Okay, so that's my atom. And then let's say that some ionizing radiation comes in, something like UV, so anything that's ionizing. And when we talk about the EM spectrum, we'll do a little bit about the fact that it's anything with a wavelength shorter than visible light can ionize. Okay, and what happens is that electron gets knocked out of its orbit. So what we have now is we have a situation where we've still got 2 neutrons, that's not changed. Still got 3 protons, that's not changed. But now what we've got is we've only got 2 electrons flying around the outside. The UV light knocked the other one out of its orbit. It ionized this atom, and this atom has now become an ion. Okay, and it's going to be a positive ion because it has lost a negative. So if we add up our positives, it's got 3 positives, and if we add up our negatives, it's got 2 negatives, which means that it is +1 overall. Okay, so +3 add -2 equals +1. So that means it's a +1 ion now. Okay, I don't want to go into the chemistry too much because I want to stick to the physics. But I think it's useful to know that ionization is radiation that knocks out an electron. An ion is something that has lost an electron. In chemistry, you also gain electrons to give you positive ions if you have a chemical reaction that might cause that to happen. But in physics, we're mostly interested in ionization that causes you to lose an electron. Okay, next up. Like I say, in physics, we don't need chemical reactions to lose electrons. We can do it simply by rubbing. So if we've got a polythene rod here, and inside my polythene rod, there's going to be lots and lots of positive charges spread out all over my rod, and there's going to be lots and lots of negative charges spread out all over my rod, and the two are going to balance each other out. So I'm going to have the same number. So if you add them up, I've got 5 of each at the moment, for example. Obviously it would be millions, but I'm not going to draw millions. Okay, so next up what we've got is we've got a cloth. And what we do with that cloth is we rub the polythene rod with the cloth. Now before I rub it, this has also got millions and millions and millions of negative charges and millions and millions and millions of positive charges. But again, I'm only going to draw 5. So it's got millions of protons and millions of electrons, but I am just going to draw 5. And this is before rubbing. Now, after rubbing, what's going to happen is some of these electrons are going to go onto this polythene rod. The protons are going to stay where they are. They're trapped inside the atom. They can't move, okay? So we're only talking about the electrons moving. So some of these electrons are going to get rubbed off this one and onto this one. So after rubbing, what we're going to have is we're going to have still have a polythene rod, still going to have 5 positives. That's not changed. Now, originally we had 5 negatives. We haven't lost any, not yet. What we've done is we've gained some electrons when we rub it. So this is now after rubbing. What's happened is we've gained some electrons from the cloth. Let's say we gained 3. And the cloth, that has lost 3, so it's still going to have 5 positives because they've not moved anywhere, and it's now going to have only 2 negatives left. So if we were to add them up, what we'd be talking about is we'd be saying that this has now got a +3 charge, and this one has now got this one's now got a -3 charge, and this one has got a +3 charge. And the reason why this one's got the positive charge, it was because it lost 3 electrons. So now it's got 5 positives, add 2 negatives, that equals +3. Whereas this one has now got 5 positives still, because they haven't moved, and neither of them have moved. But it's also got 8 negatives, which means that it's got -3 charge overall. Now, I've just used those numbers to give you an example. Obviously, it's going to be millions when it comes to actual electrons, but the key thing that you need to see is that if you gain electrons, you're going to have a negative charge, and if you lose electrons, you're going to have a positive charge, and that the protons don't move anywhere. I've still got 5 on this side, I've still got 5 on this side. It's only the electrons that are moving. And if you do that with a perspex rod, it happens the other way around. So this is with a polythene rod. If you do it with a perspex rod, the exact opposite happens. The perspex rod loses its electrons and gives them to the cloth. Okay, so let's say that I did that now, and now I've got my perspex rod, and I've got my polythene rod. What's going to happen to them? Well, I know that my polythene rod gained electrons, so I know that that is negative. And I know that my perspex rod does the opposite, so I know that that's going to be positive. So I know that these two are going to be attracted to each other. But let's say this time I do it slightly differently, and let's say that I charge 2 balls and I hang them, and they should be here like that, but they're not. They get pushed away from each other. What does the fact that they've been pushed away tell you? Well, it tells you that they must have the same charge. And it also tells you that it's the same amount, because if you look, they've been pushed away equally. And they're the two bits that people tend to forget, okay? So if you have a situation where you're suspending two balls from two bits of string, you can see that these have been pushed away from each other. So they'd like to be down here, but they can't be because they've both got the same charge. Now they could both be positive or they could both be negative, but what you know is that they're the same